next method is problem solving by trial and error. Okay, I'm going to give a mathematical example. I have a polynomial x square plus 4x plus 3. I want to find out the factors. I have a polynomial x square plus 4x plus 3. I want to find out the factors. Okay, I know that the factors will be something like this. Since it is x square, I will have some x plus m, x plus m. So I need to find out what about this m and n. So you just multiply this. I will have x into x square, nx plus mx plus mn. Okay, you can also write like this: x square n plus m into x into nm or mn, no problem. If you compare the multiplication of n and m, that should be equal to 3. So there are some possibilities. Say for example, n equal to 1, m equal to 3. Okay, that matches. Okay, or you can have n equal to minus 1, m equal to minus 3. This also, if you multiply, you will get 3. Let us go for another verification. So if you add n plus m, that should be equal to 4. Okay, if I add these two, that is not giving 4, whereas if I add these two, that is giving 4. So I am assuming that the factors are x plus 1 and x plus 3. You can consider the reverse case also, n equal to 3, m equal to 1. That's not a problem. So this solution is just by trial and error. If you see in newspapers, you might have solved this puzzles. Okay, you might have solved this Sudoku. So all these things are basically we use to solve these things. We use trial and error approach. Okay, then very important thing is solving the problems using backtracking. Okay, solving the problems using backtracking. So this is how it will work. Means this will work something like the concept of partial candidate solution. Okay, so we will go for a solution. If the solution is not matching, then again we will come back. We'll go back. We'll change the solution. Okay, until we will get the perfect solution. Okay, we will have the intermediate solution or partial candidate solutions. Okay, if it matches with the final solution, we will fix. Otherwise, every time we will go back. We will backtrack and we will solve the problem. Instead of explaining this backtracking, there is a very popular puzzle, 8 pins puzzle. Okay, there is a chessboard. I want to place 8 pins. 8 pins. Okay, without any issue. So you know the movement of queen. So if there is a queen here, okay, you know the movement. In chessboard, it will move horizontally, vertically, even diagonally. Okay, you should remember this. Okay, then it will be helpful for understanding this particular problem. We have to arrange 8 queens in the chessboard so that such that no 2 queens attack each other. This is the problem. This is the puzzle. Okay, we can solve this puzzle considering the backtracking approach or partial candidates. So what we will do, we will arrange k queens in the first k rows of the board in different rows and columns. If no 2 queens are attacking each other, then it's okay. Otherwise, we will go back and we will change the position of the initial queens. If you want to understand the theory behind this 8 queens problem, this is the Wikipedia link. You can go for it. Okay. So what I'm going to do, instead of this is the algorithm actually. Start with one queen first. Start with one queen, first row, first column. Then you just place the second queen from the second column, first row. If there is a problem, if it is attacking each other, then you change the position of the first queen. Until you get the permissible solution, you have to go back and you have to solve. Okay. So 8 queens will take more time. So what I'm doing, for simplicity, I'm just going for 4 queens problem. Okay, 4 queens problem. Let me call this question as A, this question as B, this one C, this one D. Okay, ABC. So what I'm doing, I'm just placing first queen in the first column first. So you know the movement of the queen. It can move like this. It can move like this. It can move like this. Okay. So you can place the second queen Q2 either in B3 or B4. Okay. You can place the second queen either in B3 or B4. Okay. So for example, I'm just placing the second queen in B3. Okay, I'm just placing. There are two options, either B3 or B4. I'm just placing in B3. So what happens? You just see, these are the movement of first queen, second queen. Okay, you can move like this. 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 Okay. So if you see in the third column, all the positions are occupied so that you cannot place the third queen. No option to place the third queen. So what I'm doing, I'm just going back and I'm just changing the position. Instead of placing the second queen at B3, I am placing the second queen at B4. Okay, and I'm checking whether it is a feasible solution. Okay, so now I have placed the queen here. So again, I'm just drawing the path so that you can understand. Okay, now this particular queen, it can move like this, like this, like this. Okay, now you have a place. Now you have a place for the third queen. Okay, so in C2 you can place the third queen. In C2 you can place the third queen. If I place the third queen here, you just see this is the way it will move. This way it will move. This way. This way. If I place the third queen here, I cannot place the fourth queen anywhere in the fourth column. So this is also not the correct solution. So I have to keep on going back. Okay, I have to keep on going back and I have to change the position. Okay, so if you see, instead of placing the first queen here, what I'm doing, I'm just placing the first queen in A2. I'm just placing the first queen in A2. Let me check. These are the movements. Okay, these are the movements. Second queen. If you see these three positions are occupied, I'm just going for second queen here. Okay, if that is the case, it will move like this. It will move like this. It will move like this. It can move like this. Okay, so here you can see a position. I can place Q3 here, third queen. So like this, it will move like this way, this way. So I have a position in the fourth column to place fourth. Okay, this is one of the solution. Okay, in this example, if you see, in this example, if you see, we have discussed how we can use backtracking, to solve this puzzle. Okay. So here, if you see, in this session, we have discussed various problem solving approaches. The first problem solving approach is by analogy. Okay, we'll look for the similar problem. We'll understand the solution, how they have solved the similar problem. Then we'll just modify the code, okay, so that it will work for the current problem. Then brainstorming. So I will get information from different people. Then I will go for analysis, which one is cost wise effective, which one is solution wise effective, like that I will analyze. I will give some weightage. Based on that, I will find out a solution. Okay, that is by brainstorming. Third one is abstraction. See, whatever is not required for the problem, okay, there may be more unwanted information. I'm going to filter out all the unwanted information. I'm going to reduce the complexity of the problem. Whatever required, with that I'm going to analyze the problem. I'm going to approach the problem. Okay. Then divide and conquer. Okay, so I'm going to divide a big problem into sub problems. I'm going to find out the solutions for the sub problems. That solution will lead to the solution of the overall problem. Example is this binary search. Okay, then the exhaustive search, performance wise it is very good, but the complexity is very high. It is a straightforward solution. Okay, I'm going to check each and every element. Example is bubble sort. There are many passes. Within that pass, there are many iterations. After every pass, the largest element is moved at the end. Okay, this is exhaustive search. Then the other problem solving approach is trial and error. This is what we are using for solving the puzzles and Sudoku. Then the final popular approach is backtracking. So we will use backtracking approach. We will have some intermediate solutions or partial candidate solutions. If the partial candidate solution is not matching, okay, then what we will do, we will backtrack and we'll find out the next solution. Until we will get the favorable solution, we will go for backtracking. Okay. I hope you understood this. Okay.